There's you.
Space, the final frontier. These are the adventures
Of what?
of the Starship Astronomy Cast on its continuing voyages to talk about new worlds and new lack of civilizations.
Everything is good. Right on. We're not going to have a lot of chit-chatter yet. We're going to go, because we want to get this show done and in the can before the next time opens up in half an hour. So we'll just quickly move to actually doing the show. I'm sure we'll be a little bit late, but, you know, people will survive. Audacity ready.
Audacity totally ready.
People can see us. I'm going to say hi to a bunch of people. Hello to Arnold Post and Bill Griswold and Carolyn B., Dean Peterson, Gordon Dewis, Skeeto Bibra, John Drake, Johnny Zed, K. Spence 303, Quad Libet, Larry Beckham, Mr. Tom Harbin, Paul Gracie, Rinstro, Susie Murph, and Zapfan Zapfan. Hey, everybody. All right, tell me when you're ready. We'll give like
I'm ready.
1 more minute.
Okay, maybe. Full start.
Uncle Bill Drew.
Can I show off one of my paintings while we wait?
Yeah. Uncle Bill Druin is saying Making History Kerbal Early Access, EJ and Das nerding out. I haven't had a chance to play this yet, but a bunch of people have been playing this Making History first expansion to Kerbal Space Program. So if you've been playing it, let me know.
So I'm about to pack this up to ship, which is why it's right next to my desk.
Wow.
But I made an Easter colored gas giant.
That's awesome. It was pretty funny. We were talking about about these new pictures of Jupiter that have come back from Juno. And have you seen some of these new ones with these these 8 storms at the North Pole and then these 5 storms at the Southern Pole, and how they're in these sort of perfect rotation? It's amazing. And and also the sort of the depth that the storms actually go, that the depth the atmosphere goes on Jupiter. We're really discovering that any gas giant that you want to paint is probably accurate somewhere.
I'm not convinced that this many different colors are going to exist on one world with this small of storms, because you have to be pretty hot to get the blues and greens, but you have to be pretty cold to get the lighter blues and purples. So I'm not sure this particular combination exists in nature.
It does. I'm convinced, and this is all I'm saying. This is the point. Now I think your equatorial bands are perhaps a little more mushed together than they should be. They're sort of bleeding into each other a little unscientifically. But beyond that, I'm sure that world is out there.
It has unstable convection cells. That's what that mushed together means, is unstable convection.
Where do people see? I mean, do you have any? They're all gone, right? You've sold off.
No, there's still a bunch that are available on Etsy. So if you look at the Etsy store, 739 Studios, it's a store that originally my husband set up to sell his woodworking, and then I sort of took over a corner of it with space art.
Right.
And so that's a store with my husband's woodworking, my painting, and you can see what we both spend all day Saturday doing in opposite parts of the house.
Clearly. All right, well, let's get on with this episode.
Okay, you're ready to press record now?
I am ready to press record.
I am pressing record.
I am also pressing record. We have both.
Hello, Chad. Record.
Hey, Chad. Astronomy Cast, episode 482, Alternative Ways to Space. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser Cain, publisher of Universe Today. With me, as always, Dr. Pamela Gay, the Director of Technology and Citizen Science at the Astronomical Society of the Pacific, and the Director of CosmoQuest. Hey, Pamela, how's it going?
It's going well. How's it going for you, Fraser?
It's going great. Something just arrived for me that that I've been waiting a long time for, and I'm going to hold this up so the people who are watching the live stream can see it. It is a Falcon Heavy. I think it's a resin printed Falcon Heavy that's been spray painted silver, and it is, there we go. This was provided to me by Ollie Braun, who has sort of made a cottage industry of making these Falcon rocket 3D printed models of Falcon rockets, and they're awesome. He makes bigger ones, smaller ones, different configurations, and check out his sort of his website. Do a search for Ollie Braun Falcon rocket, and he's got really cool collection. I've seen a bunch of these starting to show up, so he's clearly, you know, sending these all out to the YouTubers. But mine got cut in shipping for like for a long time because I had to go from Germany to Canada. But I'm so glad that I got it, and it will take a place of honor on my shelves of that I have behind me when I'm shooting. So thanks a lot, Ollie. All right, it is one thing to get from Earth to space, but sometimes you want to do the opposite. You want to that's the wrong intro. Chad, cut this out. Because I have to do 2 episodes.
Yeah,
so
I know exactly what happened.
Yeah, all right. Getting to space is all about rockets, but people are trying to figure out other methods that could carry payloads to orbit and beyond. Railguns, airplanes, tethers, and more. Today we'll talk about alternative methods of spaceflight. All right, Pamela, this is like one of those like regularly requested topics that I get on, you know, on the Guide to Space, at Universe Today, things like that. People are always like, they're just frustrated at the tyranny of the rocket equation, and for good reason. If Earth was any more massive, we would barely be able to launch off of this planet at all.
Well, we'd barely be able to like support our human body structure if there was too much more gravity.
Sure. But I mean, like, you know, when you consider, like, when you look at a rocket and how much of it is made up of fuel and how much is left over for payload, it is a gigantic amount of it. And that you can just barely eke out enough positive thrust to get into orbit. And the fact that we can even do it at all is kind of magical. If we lived on a more massive planet, we would be stuck. And so rockets suck. But...
And the thing is that as much as we all get frustrated with rockets and how all of the space goes to fuel instead of to cargo, it turns out they're the most tractable for getting things to space because, well, everything else you run into composite tensile strength issues. So we either have to deal with the rocket equation or we have to deal with the fact that like steel can crush under its own weight.
Right. I think someone did the math one time. I forget what the size was, but you could build like whatever is the maximum possible height of a skyscraper, and it's something like
1.5 kilometers.
There you go, 1.5 kilometers. Yeah, and we're very close to that height, and then beyond that. And of course, this is, you know, only going up. This has nothing to do with going sideways at 28,000 kilometers per hour, which is what orbit really is. It's not about going up, it's about going sideways. So what are some of the ideas? But people have been very creative, right? So what are some of the interesting ideas that people have come up with to try to get to space and maybe even move around in space that isn't a chemical rocket, that isn't an explosion, a controlled explosion in the way that rockets are?
Well, the ones that we most often hear about, think about, and wish about is the idea of either building a space elevator or a space tether system, where in the one case you have a pretty much permanently connected carbon nanotube wire of some sort that extends up past geosynchronous orbit, has its center of mass at geosynchronous orbit, and then drops down to somewhere along the Earth's equator. And then you can simply have things go up and down the cable, just like any old elevator, and life is good, and it's not a lot of power. And the issue is we can't get there from here yet because we just can't build big enough, thick enough, strong enough carbon nanotube, rope, wire, cable, whatever you want to call it. We can't build it yet.
Yeah, I mean, the strongest structure that's been proposed so far, the strongest building materials like carbon nanotubes, which are incredibly strong and could theoretically be strong enough to be able to support this, but people can't craft carbon nanotubes beyond a couple of centimeters long. Like they're just, it's still, the material science hasn't caught up. But let's say that we could. What would a space elevator look like, and what would be the sort of the savings in the economics of that?
Well, physically what it would look like is find yourself preferably a nice mountain along the equator, and you would want to build from geostationary orbit downwards, because upwards that's harder. So you slowly, ideally, have robots that are working away from geosynchronous orbit to keep the center of mass at geosynchronous orbit, build upwards with something that's big and heavy so that it doesn't have to go up very far, build downwards with this cable of uniform thickness, and then build just like a normal everyday elevators on either side of this, that theoretically the best way to do it would have the two of them counterbalance each other on this cable. So as one goes down, the other goes up. And if you were watching that, my hands went in entirely the wrong direction. The idea with the space elevator is to take what we know how to do and what we've known how to do since the 1800s and just use mass to balance things out and go up and down simultaneously. This is the same way ski lifts work, the exact same way that cable cars work. You just string things along the string, equally separated.
Right, and because you're using some kind of elevators you're using that would be going up and at the same time going down, they would be balancing each other, and then essentially the only thing you'd be paying for is the friction in the system. You'd probably use electricity. They'd be electrically powered elevators that would be going up. Now, it would take a long time. It'd take you like the better part of a week to get from low Earth orbit up to geosynchronous. But once you're up there, then you can freely float off into the solar system, and the actual energy cost was fairly low. But, there's a lot of people that are trying to work on space elevators. There's the Liftport Foundation, and there's a bunch of these other people.
And they're getting federal funds. They're getting supported by governments, because if someone can figure out the technological breakthrough that's needed, and that's all it is, we think is a technological breakthrough. We don't think there's any reason that you shouldn't be able to make cables out of carbon nanotubes. We just don't know how. If someone can solve this problem, they're going to solve a whole lot of different problems by having this super strong fiber.
But one of the things that's great is this idea would actually work a lot better on Mars or on the moon. For those places, the kinds of materials that we can build today work just fine. You could build one out of, say, Kevlar, rope, spectra. You could build, various kinds of materials that we have today, and you could build a lunar elevator on Mars, and that would actually be a great place. You build your elevator, you bring up your lunar material, and either transfer it to Earth or send it off into the solar system. Same thing with Mars. So it feels like those are actually going to be the places we'll see these elevators happen before Earth.
And having one at the moon would make a whole lot of sense. It's fairly low gravity. It's just a nice, simple way to do it. We're already working on space stations not too far away from there. We're going to start building things in lunar orbit soon enough. So let's capture that asteroid, bring it in with all the materials we need, and just start building. But here on Earth, it turns out that the idea that does make more sense than a space elevator, because the other problem with space elevators is they kind of like eat a lot of space through low Earth orbit, because you have to constantly maneuver around them. With something like a space tether, you can have something in low Earth orbit that is constantly rotating and has essentially whips coming off the two sides that balance each other off. And when they come through the atmosphere, You fly, you match their velocity, you get hooked in, then they whip you around and release you into orbit.
I mean, when you think of a tether, I'm sort of imagining this kind of rotating, like a rotating chain kind of that's just turning in the atmosphere, and one end of the chain is coming through the atmosphere while the other end is high up, and they just turn around and you can just catch a lift.
Get hooked on.
Yeah.
Sky hooks is the way Kim Stanley Robinson has referred to them in some of his books.
Yeah, and they had them in Seven Eves as well. They had a really sort of great way to approach it in Seven Eves.
And so with the sky hook, you still have issues with atmospheric drag. You still have to get fairly high up in the Earth's atmosphere to get hooked on, but they eat less space around them, so they're not interfering with a bunch of other spacecraft. And there's this good compromise between using normal airplanes that require atmosphere to function for their engines and then getting stuck into orbit rather quickly.
There's a couple of downsides with these tethers. One is that every time that you connect onto them and, the skyhook, and you grab a little bit of momentum from them, you're going to be bringing it down into the atmosphere. And as we know, the deeper you get into the atmosphere, the more the Earth is trying to interfere with its atmosphere and bring it back down. So how would they deal with these kinds of situations?
Well, you do have to have periodic counter engines to lift things up. You have to do that anyways because of all the friction that you get from low Earth orbit, because there's still some atmosphere there. And you can hook on from both sides. You can return things to the Earth this way. And so when you look at this, you can balance it out. I mean, more likely than not, you're just going to have thrusters on it that keep it in its correct orbit.
There's a couple of really interesting ideas with this. I bet you didn't even know about this because literally the news just came out a couple of days ago when we're recording. This idea of an air-breathing ion engine or air-breathing electric thruster. So it is, and ESA has actually tested this out. It's like an ion engine, except right now ion engines use like little particles of xenon and they fire them out and they use electricity, so you can carry less fuel. They figured out how to have one of these engines bring in atmospheric particles like air and then accelerate those out using electricity. And so because it's as long as you have it down in the atmosphere at a certain point, you don't need to give it any propellant, any fuel. It brings in its fuel from the air, uses electricity, uses solar panels to accelerate those particles. And so they think that you could have a very low altitude rocket or altitude satellite that it's low enough that it can get air particles in and then accelerate those out fast enough to keep itself outside of falling back down to Earth. And so right now, instead of having thrusters that you have to like send new rockets up to the International Space Station and things like that, you can have these air-breathing electric thrusters, which are just it's such a fantastic idea. I'm just like so excited about it. But the other thing just to mention as well is this idea that you can actually use the Earth's magnetic field with these tethers as well, that you can run electricity through them and you can actually get a positive boost, and vice versa. You can let the thing dip down and generate electricity into your tether. So there's a lot of options to get these things going.
And the using the tethers to generate electricity is something that's actually been tested out. And so we know these basic concepts work. We just haven't constructed them yet. And one of the things you have to think about when you're constructing them is these are things that are going to dip in and out of the atmosphere, and they're going to go around the Earth every roughly 90 minutes, which means they're going to cut through nations that may not want skyhooks cutting through their air. So this is part of why we haven't built these things yet, is we do have to take into consideration not everyone wants their atmosphere invaded by a skyhook.
Well, let's talk about railguns.
Okay. So railguns, you also may have heard them referred to as mass drivers. These are systems where you, on a small object like the moon, you build a large track on the surface and just accelerate outwards, From the Earth, you want to build in at an angle and launch yourself out the top of a mountain. And the idea is you accelerate along an extraordinarily long track. And at the end of the track, when you pop off the end, you are at the velocity you need to get into orbit. You are then, of course, going to have to fire engines once you get to that distance farthest from the surface to keep yourself in orbit and not come back down ballistically, which we talked about a lot last week. And with a railgun, all of this is done with electricity. This is the same technology that the Six Flags Mr. Freeze ride in a lot of U.S. amusement parks uses to accelerate your roller coaster
I didn't know that. Those are using those are our railguns for people.
Yes. And the way this happens is a pulsed magnetic field that accelerates you forward, and it switches where on the track the acceleration is to constantly move you faster and faster and faster forward. You can actually build railguns fairly easily if you feel like it, using coils of wire and car batteries, and then use a refrigerator magnet and a PVC pipe. So take a PVC pipe, wrap it and wrap it and wrap it and wrap it and wrap it with wire, hook it up to a car battery, and it will happily fire small magnets for you. This is a great way to make small children quite dangerous using electricity.
It sounds like a thing you've done.
It is. It is.
Yeah.
And it's fun. But yeah.
Let's talk a bit about then, you know, the pluses and minuses. Like as you said, these are electrically powered. So you can, you know, hook them up to the energy grid on Earth and use that as a way to launch your payload off into space. But what about the accelerations involved?
The first problem is actually that hooking it up to the electrical grid. At Six Flags, when they were first setting up Mr. Freeze, they realized that all of the park lights would flicker when they fired off the ride, and they had to build massive banks of capacitors. And that was just to accelerate up a roller coaster hill. In the city of Austin, when I was in graduate school, the area around the Pickle Research Center would get brownouts whenever they were testing the railgun they were building there for military purposes. These suckers require vast amounts of energy. And in those two applications, one was military, let's replace tank cannons with railguns, and the other one was just an amusement park ride. And if that's browning out your power grid, you're going to need a dedicated power plant if you're trying to get to orbit. So the power consumption is actually kind of problematic. But you're right, gravity is also a problem. With mass drivers, they've figured out that you can build some with fairly realistic, we can build something of this size to launch mass, but
cargo.
It gets, yeah, cargo is the appropriate word, because that cargo is going to pull 10 to 20 Gs, which means that something that normally perceives itself as weighing 100 pounds is going to perceive itself as weighing 1,000 to 2,000 pounds. So you need stuff that's really non-crushable, like seriously non-crushable. And that's problematic. And humans can't quite handle that. So with humans, they have been trying to figure out systems that were only pulling a couple to a few Gs. And now we're starting to look at systems that are tens of kilometers long in order to launch to significant velocity.
Yeah, I've heard that you would need things that are several hundred kilometers long, that where the structure, you know, the slope of this rises up significantly as high as a mountain to actually launch you out. The other issue, of course, is that you need orbital velocity, but you're still in the Earth's atmosphere, and so you get to enjoy what, say, returning astronauts get to enjoy when they come in. And we're going to be talking about that in our next episode. But that you're going to hit the friction of the air. And
that makes it look like there's fire surrounding you, which is a bit disturbing. And so here you are, you're getting accelerated to fairly high Gs. You then see everything outside your capsule appear to be on fire. And this has the double effect of you don't just need to have enough velocity to reach orbit, you need to have enough velocity to not get slowed down too much by the atmosphere. And one of the ways they've looked to overcome that particular problem is to just make the tunnel 20 kilometers into the atmosphere.
Which reminds me of that conversation we had about the height of a tower.
Yes. Yes.
Right?
And the thing is, people really want to build that tower. And I think my favorite, oh, that's not going to work, is the idea of building a tower all the way to geosynchronous orbit. Because if you could build a tower all the way to geosynchronous orbit, you just let go of things at the top and they're going at orbital speed.
But that's a space elevator.
They are actually thinking skyscraper, no counterweight, just build the building.
But we have nothing that could have that
You're
kind
right.
of compressibility.
Yes.
Right?
Yes.
So that's crazy talk.
Yes, but it's amusing crazy talk.
Oh, okay. Great. Well, as long as the crazy talk is amusing. All right, so we've talked about tethers, we've talked about space elevators, we've talked about railguns. What about, are there other alternative ideas to get to space?
There's the idea of a space gun. This is another one of those things that people have played with the technology for. And sometimes this gets combined with other technologies. And the idea is you have a long, essentially gun barrel, except much bigger. And you use it to channel your thing. And just like with an actual bullet, where the bullet doesn't have any engines attached to it, the explosion takes place behind the bullet, and the expansion of that explosion behind the bullet drives the bullet down the barrel. The idea with a space gun is you don't actually have the engines, the rockets, any of that. You instead get accelerated out this tube by some sort of an effect behind you. This has occasionally, in some of the things I've been reading, gotten combined with the idea of a scramjet or a ramjet. So you have the initial acceleration that takes place that gets you from 0 to some significant velocity. And once you've achieved that initial significant velocity, scramjets and ramjets use the shape of their engines to take a large amount of air, compress it down, and then channel an explosion within the nozzle. If you're within a tube, you can effectively have your bullet vehicle be that center of the scramjet engine, where the shape of your vehicle determines the physics of the scramjet, and then behind you is where all of the reactions are then taking place. I personally find this idea a bit terrifying.
Yes.
I would not want to be
for cargo.
Right? Yeah. So there's lots of creative minds out there looking for crazy talk solutions to the rocket equation.
We should talk a bit about some more hybrid approaches. For example, things like what's happening with the Strata launch. I don't know if you've been following this is the, launching rockets from aircraft, which is sort of an interesting halfway point. And this isn't a new idea. There's the Pegasus rockets, which are launching from, I think they're launching from like 747s or something like that. And so there are examples of rockets that are air launched, and there's benefits to that as well.
And we've been building these essentially droppable rocket planes since before we even went to orbit. This was the original experimental suborbital flights. They would carry something up to fairly high altitude on the bottom of a big old plane, drop this little tiny, essentially horizontal rocket with tiny wings, fire those engines, and pop up until you could see the darkness of space, and then come back down and land like an airplane. And today we take the same model. You see the suborbital version with Virgin Galactic's plants. Mm-hmm. And we also have other projects. There's SkyCat is one of the most well-known, where instead of taking things up and giving them a fair amount of velocity with an airplane, you just take them up with a balloon, get them significantly high, and then release them. You have a whole lot less air to fight against. You still have to create all the velocity, but you have less air to contend with.
And I think that I mean, those are great ideas, but the problem is they have a lot of moving parts. You know, you have to have a rocket, you have to attach to a balloon, it has to go to a certain point, has to release at the right moment and be able to finish the rest of its mission. And I think now, maybe 10 years ago, this made a lot of sense, but now we're looking at what's happening with SpaceX, with the BFR. I mean, the cost for launching 250,000 kilograms, 250 tons to low Earth orbit is going to be on the order of $7 million, I think what they're saying. So it kind of just deeply changes the economics. But you probably won't ever be able to go any cheaper than that. That is like the price of fuel at that point, because these rockets are fully reusable. And so, but it definitely kicks that can down a couple of decades on what are some alternative ways that we can get to space, that if the BFR is going to be as cheap as they say, the need to come up with these alternative methods are not going to be as great.
And I think there will always be rocket scientists and architects and construction engineers playing with these crazy, what feels like science fiction ideas, because we like to dream big. I've been really amazed at how many of these ideas are actually coming out of Russia and Eastern Europe. There's a certain allowed creativity in this kind of engineering for even the most normal staid engineering type. We want to find new and creative ways to go to space. A space elevator eventually will be, if it can get built somewhere, probably not here, the cheapest way to go up and down. But until then, it looks like, well, I think Elon Musk, as you said, with the BFR, may have found the way.
Yeah, absolutely. All right. Thanks, Pamela. We'll see you next week.
Sounds great, Fraser. Bye-bye. And now we save and switch over to a new URL, everyone.
Yeah,
we are about to move URLs.
We won't see her next week. We'll see her in
2 weeks.
About 2 minutes.
Well, that too.
Yeah. All right. So I'm going to shut this down, but hopefully there's going to be a link. Does someone have a link they can just put into the chat so that people know where's the next place to go? And then we will load it up over there.
And what's our episode number?
That was 482.
Thank you.
All right. I'm going to shut this broadcast down. We'll see you over at the new location.
Yep. Talk to you in a bit.